So even though this was technically part of yesterday's sheet, we're starting with 132 because 132 starts a new group of problems, so I had put this off for today. The equation that's working this next group is the combined gas law. P1V1 over T1 equals P2V2 over T2. The temperatures have to be in Kelvin, so if they give you Celsius, you have to add 273. The volumes could be liters or milliliters, it doesn't matter, they just have to be in agreement with each other. The pressures could be any of, I think there were 8 things that we memorized. Atmospheres, pascals, millimeters mercury, and torr were probably the most 4 common. Doesn't matter which one they do, there just has to be a consistency between the two. You can also shrink this law down. If they give you 2 matching temperatures, or 2 matching pressures, or 2 matching volumes, like the exact same number, the easiest thing to do is just ignore that. Don't even put it into the problem. So if we go to do 132, my first notice is that the 30 Celsius is in there twice. I'm just not going to use that. I'm going to just use the other numbers. 385 milliliters, milliliters is a measurement of volume. The 385 milliliters is going with a pressure of 640 mmHg. mmHg is one of the pressure units. For the second sentence, we have a 30 again, which I'm ignoring. The 380 is in the mmHg spot, so the 380 is in contrast to the 640. Those were both pressures, and I just don't know that. So for me to do the algebra to solve for this, I multiply the 2 where I knew them both, and then I do an opposite by dividing by the 380, because 380 is multiplying, I've got to divide. 133, my first observation would be that the 640s are the same, so I'm not even going to use the 640s. I'm going to put the 385 in for milliliters, that's a volume. 385 had a temperature of 30, so I'm not going to put a 30, I'm going to put 303, because 30 has to add 273 to be Kelvin. In the second sentence, the 585 is the milliliters, which is the top, because that is a volume. And then I have an X on the bottom. To solve this, I cross multiply. 385 goes with X. 303 multiplies 585. After you multiply 303 and 585, you'll have to do an opposite and divide by the 385. 134, I noticed the 385s are the same, so I just ignore them. 30 Celsius goes on the bottom, but as 303 Kelvin again. 640 goes on the top, because 640 millimeters of mercury, that's one of our pressures. The other pressure we don't know, but we have a 40 Celsius, so 40 plus 273 would get me these numbers. To solve for X, since it's dividing, I just have to multiply 640 times 313 and divide by the 303. For 135, we have all the numbers are different, so I'm going to use them all. So 385 milliliters is a type of volume. The other volume from the other sentence, we don't know, but they want milliliters, so that's good. The 30 Celsius is the temperature. Temperatures go on the bottom, make them Kelvin. 50 Celsius goes on the bottom, make it Kelvin. The 640 millimeters mercury is a pressure, and in place of 640 for the other fraction is a 680. If you're going to solve this for X, the 680 has to go and divide down. 323 has to multiply up. So I would do 640 times 385 times 323. Divide by 303 because it's on the bottom. Divide by again for 680 because it's on the bottom. 136 is basically the same question. The only difference on 136, do the same thing you do on 135. But since it asked you for liters and not for milliliters, when you're done you'll have to divide by 1,000. So 136 otherwise is the same as 135. A little bit of cross multiplying, things like that. 137, we're switching equations to the equation PV equals nRT. The P has to be atmospheres only, the V is liters only, the N is a number of moles, which may involve the periodic table. R is just 0.0821, memorize it. temperature continues to have to be in Kelvin. So if I go to do 131, we would put 2.64 here. This is unknown. This is the 0.245. Temperature is 58, has to add 273 to be 331. To do the algebra, we multiply the three numbers on the right side because we know them all, and then do an opposite to divide the 2.64. For 138, we have this as a variable, 2.5 is the volume because that's the liters, number of moles is 0.72, this is just a memorization number. Temperature, we have to do 38 plus the 273, as always. Again, multiply the three numbers on the right of the equals and divide by the 2.5 that we do. For 139, pressure is a 0.877, volume is a 3.65, number of moles is a 0.48, the R is the memory number, and it's a T that we're after. So here we'll start by multiplying the two numbers on the side that was complete. Always multiply the complete side first. Multiply the 2 on the complete side, and then divide by the mole count, and divide by 0.0821 as well. And that should get you a temperature, but then there's a twist, because on 139 they want a temperature in Celsius, and this equation can only give you Kelvin. So you'll have to subtract 273 to convert back. 140, we have pressure known, 0.334, liters is known, 5.68, moles is not known, so that's our variable. This is always known, 0.0821. The Kelvin, we would do 57 plus 273. Again, multiply both numbers on the complete side, multiply these two that we have, and then divide by the 0.0821 and divide by the Kelvin temperature that we had, and that'll get you a mole count. 141 is the biggest mess because I didn't give you anything, not directly. I gave you grams. The only thing that grams can turn into out of these is moles. We can cancel grams with a little many-dimensional analysis to make moles using our periodic table. There's 1 mole makes 32 grams for oxygen because oxygen is O2, remember? So a single oxygen is 16. O2 is going to get us a 32. So that's going to be a 1.69 really long number. That's going to step in for the mole count. 1240 torr. Torr can't go anywhere, but torr is a type of pressure, so we can convert torr to atmospheres. If we take 1240 torr and put torr on the bottom, 760 is the magic number for torr we memorized. To get to 1 ATM is the number that we memorized. If you punch that in, that's a 1.63 really long number. The 1.63 really long number could go in for the pressure. 28 Celsius, we'll add 273 to get 301. So we have 301 here. We always know this. We had this number a second ago. Multiply those three numbers together, and then divide by the misfit over here. We had an ATM number, so we would divide by that. You do all that, and it feels like we'd be done, but that would give you liters, and your calculator screen should show you something around 25. But to get from liters to milliliters, we still have one more dimensional analysis step. To turn liters into milliliters involves multiplying by 1,000 to finish that page. 142 is probably the worst problem of the test. So 142, we're trying to figure out a density, but not at STP, and that creates like a double complication. So the first thing we could do is figure out a normal density, which isn't bad. Okay, I mentioned CO2. So CO2 should make you think about heading to the periodic table because that's a formula we know. So carbon's a 12, oxygen is 16 times 2. You total that up, there would be 44 grams in 1 mole. We've done that a lot. That's called a molar mass. we need to cancel moles and try to get to liters. The number for moles is always 1. The number for liters is 22.4, always. You do the math on that, and that would show you 1.96, a number that goes forever. That would be grams per liter, and that's a density. And we would be done if the question said, calculate the grams per liter at STP. Unfortunately, this problem is not at STP. So we need to use the gas law, PV over T equation, to get ourselves converted from STP to the pressure and the temperature involved in this question. So the old P1, V1 over T1 stuff. So where we're trying to get is 34 Celsius. So we need to do 34 plus 273. Where we're coming from is standard temperature, which the standard temperature we memorized is 273. The 2.57 atmospheres, that is a pressure. So I'll live in the P slot. The pressure in the normal standard zone is 1. 1 ATM is a number we memorized. The volume where we're coming from is the liters where we're coming from, and there's no number here, but there's always in math and chemistry and everything an invisible 1 when we need it. So we have a volume of 1 originally. The volume we're trying to make, we don't know what that is. That's why we're trying to do this gas law. So cross multiplying, 307 would go up, 2.57 would go down. 307 dividing 273, also dividing 2.57, that should show you a 0.43 liters. So density is always the mass dividing the volume. So we need to take this mass that we got from up above, divide by this volume that we just got from below, and if you divide those, we're going to get the density at the unusual temperature pressure combination. 143, we're stepping into chapter 12, the final chapter that we did a test on of the year, and we're going to use a lot the table on page 316 for specific heats and latent heats for things. So in these days, calories and grams went together nicely. If we had a misfit on calories and grams, we would have to convert a unit there. If you want a longer explanation of that, you could look back up the chapter 12 practice test video. It has a pretty long explanation on that. Joules and kilograms went together. If we didn't have a good match on that, we were going to have to do a conversion to make things work out. But joules can get you to kilograms. Calories can get you to grams. We're using the table a lot on 316. So for 143, I have steam condensing. So 48 grams could head me to calories if I multiply by the right number from that table, which is 540 for steam. That would get me to calories. But I'm trying to get to kilocalories, so to finish that problem correctly, I'd have to divide by 1,000. For 144, I have grams, and I'm trying to get to joules. Grams can't get me to joules. So I'm going to do a 476. I would have to turn the grams into kilograms to get this started. So the 476, I divided by 1,000 to get a 0.476. And then to get to joules, I would use the number from the table, which is 2.26 times 10 to the 6 for steam there. That would get me to joules. But I have another step to go to get to kilojoules. That's going to take me dividing by 1,000 again. And you could do these with dimensional analysis if you wanted to. My paper did it, but I think the chapter 12 test I might have. So you can do it with or without the dimensional analysis. It's sort of a toss-up. You got to decide that for yourself. 145 I'll do with dimensional analysis just for the sake of a little bit of variety. So I'm starting you with moles. The only place moles can get you is to grams. 1 is the number for moles. Grams, we're going to need to use the periodic table. For water, H2O, that's 18. Because 16 for oxygen plus 1 for the 2 hydrogens. So I can get rid of moles and I can get to grams. I'm happy with grams if I want to get to calories, but I don't. I'm trying to get to joules. So kilograms can access joules. So I need to cancel grams to get to kilograms. 1,000 grams makes 1 kilogram. Kilograms can get to joules if I use the right number from the table, which is 2.26 times 10 to the 6 joules for 1 kilogram of mass. The 1 wasn't in the story, that's just the way that it goes. To finish that, I need to get from joules to kilojoules, and there's 1,000 joules in a kilojoule. If that felt more comfortable than the way I talked through 144, then do 144 with dimensional analysis. If 144 with the talk through felt more comfortable, 145 I have the math instead of the talk through of just the different steps you'd have to do, but you can do whatever you want. 146 just involves you memorizing .0075 as a number times 75 ATMs. For every 1 ATM of pressure, you get a change in the melting point of .0075. So just multiply them, and the answer is always negative because it lowers the melting point and it makes ice melt at a colder temperature because the pressure helps that along. That's why ice skating works. 147, we're trying to get from grams to the calorie family, so that's good news. So we need to get from ice at 0 to steam at 100. This is going to take a 3-step plan. We'd have to melt the ice. That's going to be 34 times 80, with 80 coming from the table. Then when we change temperatures from 0 to 100, this is the equation for warming things up. Take the 34 mass times a 1 from the specific heat for water from the table, times 100 for the temperature change. Then the third thing we'd have to do is boil that water, which is 34 times 540. The 540 coming from the table as steam's number. Add those 3 things up, and if we wanted calories, we'd be done. But it has to change to kilocalories, so you'll have to divide by 1,000, or you'd have to do a little dimensional analysis thing. You have grams, you want to get to, or you have, calories, and we want to get to kilocalories. 1,000 calories makes a kilocalorie, that's why we're dividing. Again, if the little conversions are bothering you, again, the chapter 12 video had a pretty good explanation of that in detail. 128, we're trying to get to a joule family, so we have to start from a kilogram family, and this probably starts from grams. So we're going to have to get grams turned into kilograms by dividing 1,000. So the 75 is going to be used in my world on this paper as a .075. 0.075, we're going to go through the same steps as 3 steps as 147. You'd have to melt the ice. That's going to be .075 times 3.35 times 10 to the 5th. 3.35 times 10 to the 5th comes from the book. That's the melting ice, latent heat. Then we'd have to warm that up. So that's this equation again. Mass of .075. Specific heat of 4180 now that we're in the kilogram family, and a temperature change of 100. Step 3 is to multiply .075 times steam's latent heat, 2.26 times 10 to the 6th. Add that all up. If it were joules, we'd be done, but it asked for kilojoules. So if I have a question where we have joules, and I want to get to kilojoules, 1 kilojoule is 1,000 joules, so I'm having to divide 1,000 again. 149 is the 5-step plan. What we have here is ice that's too cold, so we're going to have to warm it up using this for step 1. So that's going to take 26 times 0.5 for ice times 15 for the temperature change. Step 2, we're going to have to melt the ice. That's 26 times 80, 80 coming from the table. Now we have water. Step 3, we're going to use this equation, but with water's numbers. 26 times a 1 times 100 for that temperature change to take water from 0 to 100. Step 4 is 26 times 540, because 540 is the steam making number. Then step 5 is to warm up the steam. You can only create steam exactly at 100, and we want to get the steam up to 120. So 26 times a 0.48 for steam, that was on a little piece of paper I gave you once, times a 20 for the temperature change to get from 100 to 120. Add that all up, and you'd be good. 150, we're trying to get a calorie count, so we need to start from grams, but my question starts with kilograms. So if I start you with kilograms, we need to get to grams, cancel kilograms, and there's 1,000 kilograms in a gram. So the 0.754 has to multiply 1,000 to be 754 to start. Then it's easy money. Just take 754 times 80. 80's from the chart. That's the number for freezing water, melting, freezing. The 80 is that latent heat, so you just multiply that up. Again, remember, for every problem, you want to have 3 significant digits and a unit. So before you're done with your test, you might want to skim for that. You know, if you have an answer on your screen like 14793, you always copy, and in the third position, this is where we round. If you see something here that's 5 or more, we go up before we zero that out. If this had been a 0, 1, 2, 3, 4 number, we'd have kept the 7 the same and then zeroed it out. But every answer should be rounded in the third position and have a unit on there. If that's not enough, we'll zoom sometime. See you guys.